Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and in this video, I'd like us to look at your children as mathematicians and the practices we use that will help build that success and that confidence in your child. Now, before I get started, again, I'd like to welcome those who are new to the channel. Welcome to those who have recently subscribed. Thank you so much for doing that. And I hope that you'll find these videos useful and will share these with others. Give them a thumbs up. Again, I appreciate it. It really helps the channel. Now, as we think about those practices, in one of the first videos I did, we looked at the 5 strands of math proficiency, thinking about there's a lot more to being mathematically proficient than just knowing rules and procedures. And I will give you the link below in the description to link to this video to learn a bit more about the 5 strands of math proficiency. But as we see, it's not just that procedural piece, it's the conceptual understanding, strategic competence, having strategies and different ways of thinking about problems, the adaptive reasoning, and then not giving up when things get difficult, that productive disposition. So as I said, I'll leave that link in the description below. But one of the things that we think about is, what does it mean for your child to be a mathematician, right? A lot of times we think of math as full as rules and procedures. You just have to remember all the steps. But I want you to notice in this quote that word creative. Being a mathematician is a creative activity. Okay, it's one thing to learn the math we already know, but it's another thing to create new mathematics. I think of the Hidden Figures movie, where they had to figure out the mathematics to bring the spaceship back, right? To bring them back, not just to send them into space. So think about it as a creative activity. Throughout it, it's flexibility. Right. Sometimes when children get stumped, it's because they're trying to apply a given process or procedure to something that isn't right for that procedure, right? So we need flexibility. And that flexibility is what will help your child become effective problem solvers. So I'm going to look at the 8 math practices that were mentioned in Common Core, but they are not unique to Common Core. And the NCTM, National Council of Teachers of Math, have sent out many documents on practices or process standards that are important. So we think of content, what your children should know mathematically, and then how they engage in mathematics. And that's what these are about. So one of those practices is making sense of problems and persevere in solving them. Perseverance is part of the productive disposition. And think about, if I think back to my math education as a child, it was a lot of problems were modeled, procedures were modeled for me, and we practiced solving them till we really didn't need to think about anymore if we caught on to those procedures, right? What this is saying is a child who is proficient at math, they are the ones who can make sense of the problems. They find ways to enter a problem, ways to attack a problem. They can read the problem or see the problem and be flexible in how they come at it. So you'll find that when you look at that procedural fluency, quite often I'll talk about procedural flexibility. It's knowing more than one way to attack a problem and then picking the most efficient or most appropriate for that problem. Another is reasoning abstractly and quantitatively. It's understanding how we can use numbers to represent a problem. It's understanding what those numbers might represent, the units involved, how they fit together. So it's thinking about quantities, how to manipulate them, the operations linked to the quantities, right? The meaning, but the flexibly use those different meanings and use them to work with those problems. Constructing viable arguments and critiquing the reasoning of others. This is being able to defend your thinking. Now, quite often, I could ask your child, and I have asked children, well, how did you get that answer? Or or how do you know? And the child will say, I just knew it. My brain told me. Now, see, when you are critiquing the reasoning of others and defending your thinking, you have to consider your audience. And I had a teacher one time say to me, when they say, I just knew it, or my brain told me, the audience they are speaking to is an audience of one themselves. And for your child to be mathematically proficient, we need them to think about who their audience is. Who are they trying to convince? And really thinking of how do you convince your peers that your argument, that your conclusion, your solution makes sense? And then getting them to be able to analyze what their peers are telling them and decide, does that make sense or doesn't it make sense? So that constructing viable arguments, we might think of that as proof that we did in geometry, but throughout their mathematics education, your children may be asked, how do they know? How did they get there? It's also a wonderful way for them to find their own mistakes. It's one of those approaches we use in productive struggle, how to support productive struggle. And I'll leave the link below to that video also. And then modeling with mathematics, understanding that you can use math to represent problems. These may be equations eventually, they may be diagrams, they could be charts and tables. It could be pictures that we draw. So your young children may be asked to draw pictures to represent the story, to model the math that leads to those equations. Later on, they might be looking at relationships, using those tables, using charts, coming to conclusions. The other is using appropriate tools strategically. Quite often in classrooms or as adults helping our child, right, or helping children, we decide the tools they need and we give them to them and then hope they know how to use them or we teach them how to use them. What this is saying is a practice, and with these practices, it's how your child should be engaging and doing mathematics, right? It's how they actually approach math activity. And one of the things we need them to be able to do is know the tools that are available and which tools are most useful to them. Going to pick some of those materials that are in the classroom, things like pattern blocks or tangrams or rulers or calculators even, strips of paper, tools that might help them make sense of the problem and help them solve it. But they need to be aware of the tools that are available to them and they need to choose them. Notice they use the tools strategically, but they have a reason for it. Another is attending to precision. There's a precision of language we need your children to develop. There are efficient ways to get at those solutions, ways to tackle problems. And there's also precise notation. To me, this is what rigor is about, is precise notation, precise terminology, precise use of language. If a child is proficient, they understand the relation between those, and they're very precise in their notation, okay? So another is looking for and making use of structure, understanding the relationships they're seeing between the patterns, between what they're doing, understanding things that will lead them to commutative property, associative property, understanding that if I know 7 and 3 is 10, then 3 and 7 is 10, that they start through their experiences being able to see the structure, being able to understand that double 199 is the same as double 200 minus 2, looking for structure in math, looking for patterns is what a proficient math student will do, mathematician will do, and then using that to come up with conclusions, to look for those patterns, to use that through that repeated reasoning for your child to come up with some of those rules, not just be given a rule and practice it. right? That repeated reasoning helps us come to those conclusions, those rules that again changes. These practices move us and move your children from being shown a rule and a procedure and practicing it, which doesn't take as much thought as using reasoning and looking for the structure and deciding what tools you can use. Think about the level of engagement and the level of thought that if your child is proficient, they are able to do that without getting too frustrated. They will persevere. Okay. So, math is a process, not just the content to be learned. And as you look at this by Hans Freudenthal Institute, very important in mathematics of young children, education of young children. What I want you to think about here, it's not all the words and thinking about those pieces, but what it's saying is math is a process, and we want to make sure your child has opportunities to act like a mathematician, right? Not be shown in practice, not a mimicry activity, but a creative activity. Okay. As I said at the beginning, one side of learning mathematics is learning what is already known. I mentioned the Hidden Figures movie, but I also remember watching the SpaceX launch with these booster rockets and the rockets landing on the launch pad. Phenomenal use of mathematics and precision and creativity. So one side is learning the math that is known. But being a mathematician, right, it's about creative ways of using the math we know or creating the mathematics that is needed to solve unique problems that we have and problems that are 21st century problems, not problems of centuries ago. So as we're thinking about rigor, giving them those skills that they need, don't forget that one of those skills for the 21st century is imagination, is creativity, right? It's using that reasoning to look for patterns and coming up with new ways to think about it. So, what can we do to help your children? One, we want to nurture creativity and curiosity. Let them explore ideas. Come up with conjectures and test them. It's okay to be wrong. So much is learned from things that don't work as much as what is learned from things that do. We want to give them opportunities to explore, to play, okay? And thinking of play, not just as something that's mindless, but it's a very important activity because it's where you experiment. It's where you decide if things work and don't work. We want them to be risk takers. Some children, the minute they don't know something, they really shut down. They want to do something else. And part of it is they've been led to believe that math is something you do quickly, you know immediately. You've got to know those facts, those procedures. But when you're problem solving, things can't always be solved in seconds or minutes. We need to take risk and see what works and what doesn't work. So we want to make sure we encourage your child to being comfortable with being uncomfortable, to know it's okay and we can work through this problem. Just think it through, try things. And remember, it is a social activity. We can't critique the reasoning of others or give out those viable arguments if we're doing it just independently. It is social. We need others to critique our reasoning to help us grow. So, some things we can do, some practices that will lead to success, and make sure your child is mathematically proficient, because remember, in those 5 strands of math proficiency, it includes productive disposition, perseverance, believing in your own ability to do the math, right? It involves that strategic competence, understanding. Those incorporate a lot of these practices we've talked about, right? Adaptive reasoning. So you're going to see those 5 strands involve these practices, and they've just been delineate a little bit more, broken out a little bit more. But I hope that helps you understand or see some of the practices your child may be engaged in, or that we hope they are engaged in as they're learning mathematics. It's that knowing the answer is not as important as exploring the question. Thinking is what's really important, and mathematics is one of the most thinking disciplines. We want to make sure we continue to encourage your child to think, to reason, and to believe that if they keep at it, if they persevere, they'll be able to do it. So again, I hope you found this video helpful. If so, please give it a thumbs up. Please pass it on to others, share it, subscribe, click on the notifications bell so you'll know when other videos are available. And thanks so much for watching.